we're going to be taking a closer look at parabolas. Now, get your conic sections flipbook out, and under the Important Information tab, you need to write down these definitions. So go ahead and pause the video and write down all of these in your Important Information flap. Okay, first of all, a parabola, it's a set of all points such that each point is equidistant from a fixed point called the focus and a line called the directrix. So what that means for us is that our focus and our directrix are going to be the same distance away from any point on our parabola. So this distance would be the same as that distance. This one and that one would be the same. So it's equidistant from a point called the focus and a line called the directrix. The focus will always lie on your axis of symmetry. Remember, the axis of symmetry is what goes right down the center of your parabola and splits it in half, and is p units from the vertex, and then the directrix is perpendicular to your axis of symmetry and is p units from your vertex also. Now go ahead into the y minus k squared equals 4p x minus h. Go to that tab. On the top of that flap, we are going to draw a picture to show what we're going to be working with. And what we're going to have first is a parabola. Now when we have a parabola that has the y squared term, it is going to be a sideways parabola. So go ahead and sketch yourself a sideways parabola. Put a arbitrary point that's the focus inside there. This isn't going to be necessarily a physically accurate representation, but it will give us a visual of where all of these things lie. So I need a directrix also. And now my vertex. We've seen h and k a lot, and usually it has some relevance to whatever we're doing, and it has relevance with parabolas. That's going to be the coordinates of our vertex. So our point right here is h comma k. Now one thing you have to realize is that these are in terms of minuses, so we have to take the opposite of both h and k. So it's going to be h comma k for our vertex. And if you look back to what our definition of the focus was, it lies on the axis of symmetry, so I'm going to go ahead and sketch my axis of symmetry in here. And then it says, is p units away from the vertex. So from my vertex to my focus is a distance of p. So that's where the p units comes from. What that means for the coordinates of our focus, you think of this in terms of x and y's. To get to my vertex, I have to go over h and up k units. To get to my focus, I have to go over h plus p more. So my x-coordinate of my focus is h plus p. And then my y-coordinate, I don't go up or down compared to my vertex, so my y-coordinate stays k. Now let's go and look at the directrix. That's the vertical dotted line I have here. Now our directrix, since this is a vertical line, when we have a sideways parabola, our directrix is a vertical line, so it's going to be an x equals. Now we have to think about, how do I get from my vertex to my directrix? Because we always reference our vertex. Well, if you look at your definition of the directrix, it is also p units away from your vertex. So instead of going over h, I have to go over h but then subtract p back off of it. So for my directrix, it's going to be h minus p to figure out where the directrix is at. My axis of symmetry, since it's going to be a horizontal line, my axis of symmetry is going to be y equals. And if you look at our y value, it's going to be k. So we have y equals k. So this is kind of a picture of what our graphs will look like when we have the y squared term. Now keep in mind, the graphs can open to the right or they can open to the left, but when it's a y squared, it will always be a sideways parabola. Now on the bottom of this flap, what we need to do is we need to write down what that important information is. So first, our vertex is at the point h comma k. And you want to put a little note here. Use the opposite of both. The next, our focus, well, we already looked at that. That was h plus p comma k. And our directrix is line x equals h minus p. And our axis of symmetry is y equals k. Now up here we have the note here to use the opposite of both h and k. You only do that once. So once I have found my vertex, I don't continue taking the opposites over and over. So if I find my, let's say my equation is y minus 7, and then over here I end up with an x plus 2, my h would be negative 2, and my k would be a positive 7. So down here, my h would still remain that negative 2. One thing that kids do is they'll take the opposite of it for the vertex, and then they'll take the opposite again for the focus, so then they'll change it back into a positive 2. And then they'll take the opposite again for the directrix and change it back to a negative 2. That's not how it works. You only change it one time, and then the negative 2 is your h. So it stays h throughout the whole thing. Alright, now go ahead and jump to the next flap, the x minus h squared. So in this one, the x term is squared. On the top part of this flap is where we're going to do the picture. So these are like our normal parabolas. So draw your regular parabola, go ahead and draw your axis of symmetry, put a point inside here for the focus, and put a directrix out here that's perpendicular to your axis of symmetry. We're going to start out the same way. H and K is still our vertex. So that's going to be our reference point for everything else we do. Well, like before, the focus is p units away, and the directrix is p units away. So we still have that same relationship there. But now when you look at the coordinates, compared to our vertex, the x coordinate doesn't change. So that one stays h. And this time, the y coordinate changes, because to get to my focus, I have to go up k, but then I have to go p more. So I would have k plus p. And then my directrix kind of works out in a similar way. This time though, my directrix is a horizontal line, so it's y equals the k minus p. Now with our last one, the directrix was x equals. With this one, the directrix is y equals. That can be a huge key when you're working some of these problems as to which equation you have. Our axis of symmetry is a vertical line this time, so that's going to be x equals h. So that's what our picture should look like for the x squared one. Now go to our important information. First of all, our vertex is the same as it was before, h comma k. And again, we use the opposite of both. And then our focus is h comma k plus p, because remember this time our y value changed. Our directrix is y equals k minus p. And the axis of symmetry is x equals h. Okay, here's our first set of practice problems. It says identify all the key features of the parabolas with the given equations. We will do the first one here together, and then I'm going to have you pause the video and try the second one on your own. So the first thing we have to do is decide which equation are we going to use to tackle this. And your key is which term is squared. Since it's the x term that's squared, you want to use the equation on the bottom flap of your flipbook because that's where the x term is squared there. So we're going to be using the x minus h, that quantity squared, is equal to 4p y minus k. Now if you look at our setup compared to what the formula calls for, it's fairly close in the fact that we have a squared, we have a y, we have a plus or a minus sign. We have a 10 with our k. So what we need to do is we need to just tweak it just a little bit. So what you have to think about is x minus what number here would give me just x squared? Well, that would be a 0. Since there's no number over here, our h is a 0. And then equals 4p. Well, what you need to see is that 4p is represented by the 15. So what we need to do is we need to figure out what is the value of p, because that's used to find our focus in our directrix. So what we have to do is set up 15 is equal to 4p, because whatever p is, when you multiply it out by that 4, it gives us a 15. So the 15 has the p disguised within it. And in order to do that, divide both sides by 4, and we get 15/4, or 3 3/4, whichever way you want to write it. And then our k lines up with the 10. But now remember, when we go back to this, we have to use the opposite of h and the opposite of our k. So for my vertex, it's at h comma k. Well, the opposite of my h is still 0, so that didn't affect it. But now the opposite of my 10 here is really a negative 10. So I have identified my h and my k. And with the fact that I have p right down here, I can now look at my formulas and figure out all the relevant information that goes along with this. So my focus, according to my flipbook, it says that it's at h comma k plus p. Well, as I fill that in, my h is 0, my k is negative 10, and the p is 3 3/4. Well, when I simplify that out, the 0 stays, and then negative 10 plus 3 3/4 gives me negative 6 1/4. So that's where my focus is. And then the second to last one, my directrix. My directrix, according to my flipbook, says that I have y equals k minus p. Well, I'm going to have y equals, and now my k, I pull off from my vertex again, is negative 10, minus, the p is 3 3/4, so my directrix is y equals negative 13 3/4. And then the last piece of relevant information is my axis of symmetry. And according to my flipbook, that is x equals h. And I pull the h from my vertex, so my axis of symmetry is x equals 0. So here I have all of the relevant pieces of information that go along with my parabola. Now what I want you to do is the same type of thing with this second equation here. First thing you're going to have to do is isolate the squared term. So you've got to think to yourself, I've got 1/4 times this squared term. How do I undo multiplying by 1/4? So first isolate the squared term, and then go through the same process we did here. Find your vertex, and then use that to do the focus, the directrix, and the axis of symmetry. So pause the video and give that a shot. Alright, the first thing I did over here was I got rid of timesing by that 1/4 by multiplying by the reciprocal, which is 4/1. So my new equation turned out to be 4 times x plus 6 equals y plus 7 squared. I had to get that squared quantity isolated. Then I looked at my flipbook and I decided that I was going to use the y squared term one because the y term is the one that's squared. So I lined up my equation right underneath the equation from my flipbook, and then I started with looking at p, finding the value of p. Well, I know that this 4 represents the 4p, so I take 4p equals 4, divide both sides by 4, and we get p is equal to 1. I'm going to end up using that later for my focus and my directrix. Then I went to my vertex, and my vertex says it's at h comma k, but I have to remember to use the opposites. Well, my h is a negative 6, and my k is a negative 7. From there I went to my focus, and it says it's h plus p comma k, so I filled in my h, filled in the p, filled in the k, and found my focus to be at negative 5, negative 7. Then my directrix says that I've got h minus p. When I fill the h in the p in, I end up getting x equals negative 7. And my axis of symmetry is y equals k, so I had y equals negative 7.